So let's see one example. Draw the board plot for the unity feedback system. Okay, we have the open loop transfer function in this way. So when you have this, I usually teach the student to use the first order transfer function to plot. So first step is you simplify the transfer function to first order system. Okay, so now let's see. From this we have the k s plus 3 s plus 1 s plus 2, right? So let it move to the simple one. You take out first order, so we will make it to take out the 3, then s over 3 plus 1. So s, so this one is you take out the 1, it become sorry, you take out the 1, it become the 1 s for 1 plus 1, and then there will be 2 s for 2 plus 1. Okay, so now you have the equations becomes like 3k over 1 2s, so 2s, then s over 3 plus 1. Numerator part we have, because s already like this, I write in this way, so you just write s plus 1 plus 1, and then s over 2 plus 1. So now your system become in this way. Then you will have 4 transfer function where it is first one, second one, third one, fourth one. How to say that? So g1 is equals to 3k over 2 per s. Okay, so second equation is s over 3 plus 1. Okay, sometimes I ask the student follow the, because when you have this a first order system, this is the break frequency. Break frequency, so means we will have try to arrange the break frequency like 1. So g2 equals to 1 over s per 1 plus 1, and then 2 is because now your break frequency is at 1, 2 and 3. Then g3 equals to this one, right? 1 over s per 2 plus 1, and g4 is the break frequency at 3, so it's a 0. So 0. So this is the first order system. So now look at this. I have shown how to get this one, and then next, this is the frequency that you can get. Okay, what we are going to do is we need to find, if you want to plot the magnitude, you need to find the starting point. If you want to plot where to start, so starting point, usually this gain will let you know. Okay, so we pick the g1, 3k per 2 over s, then this s make it to the omega 1, 3k per 2 omega. So from the question, usually will tell you where to start. Okay, like this one, we start from 0.1, then you substitute omega is 0.1 equals to 15. So for this case, you assume the k equals to 1. Okay, you assume k equals to 1 if they don't let you know what is the k value, so you assume. Okay, then from here 15 is not the point yet, because when we plot on the semi-board, the magnitude here is the dB, so you need to make it to the dB. 20 log 15, so you get 23.52 dB. You will start from the average is 24. Okay, 24 dB. Now we know the starting point. Next we go to plot the rest. Okay, we find out. I usually suggest to create the table. Then you start from the first one is the frequency. Okay, here is the frequency. So this is the starting frequency. Okay, so what is the net frequency? These are the break frequency which you can get from question. Means open loop transfer function. Okay, so we know that is the pole, and then this is the 0. Okay, then description here you write is the because you have 1 over s, you have the poles and you have the 0. So 0, the pole is at 0, -1, -2, and the 0 at -3. Then okay, let's us know that pole, if pole is at a 0, means you follow this model. Pole at the pole, because this one is 0, this one is pole. So pole at the 0 is a 1 over s. 1 over s, if 1 over s, your magnitude will start from 0 and then decreasing 20 dB per decade. This is 1 decade. This is 20, negative 20 dB. So this slope, keturunan slope, is the negative 20 dB per decade. So you start from 0, you draw this. And for the phase, it will start from the negative 90 degree. So you write it here, negative 20, and then to the rest, negative 20, negative 20, negative 20, negative 20. Then next, if the pole at negative 1, if pole at negative 1 means it refer to the model pole. Pole is this. Okay, this one is 0, right? This one is pole. 1 over. Okay, and 1 over s per a plus 1, and then you can have the a here, okay. A is your break frequency, like just now if 1, so you will choose the 1 radian per second, and then you decreasing negative 20 dB per decade. Okay, so come back to here. That means we start from negative 1, only will decrease negative 20 dB, not before negative 1. Okay, is start from negative 1. So same as the negative 2, same model, which is pole happen at negative 2. Okay, so from negative 2 decrease this slope, so not before it, not before it. Then this one is 0, so 0 is this model, 0 is this model. So 0, we see that A is the break frequency, A here. So just now it's 3, right? So you find the 3, and then it will increase with the, this is 1 decade, and then this is positive 20 dB per decade, because here is the 20. Okay, so back to our question here. Start from the break frequency 3, positive 20 to rest, not before. Okay, so once you have done for all the pole and 0 in your system, then let's see from here, you sum them up. So negative 20 plus 0, 0, 0, negative 20. Negative 20 plus negative 20, negative 40. So negative 60. So this one is negative 60 plus 20, negative 40. Okay, then this is later on we will follow this one to plot our magnitude. Okay, so next go to the phase. When go to the phase, we also need to know where to start. So we can see that the lower one, smaller, is pole at 0. So when pole at 0, just now I already shown here, is when pole at 0, okay, you will start from the pole. This is pole, right? Start from negative 20. If today your question is 0, s 0 at origin is so you will start from 90. So if your system do not have any pole or zero at origin, then you only have k the gain. So the gain is always straight line at the magnitude, and also always is the 0 degree. So later on when you fill up the table, you will see how does it look like. Okay, then now come back to this. So negative 20, we just now we knew it, so we will start from the negative 20. Then now we build the table again. Okay, we build the table is only involve the break frequency. So like just now we know break frequency at 1, 2 and 3, right? So the table here you don't write 1, 2, 3, but you need to let them know it's 1 decade before and 1 decade after. Why that happened? Because refer to this slide. When you have the 0, let's say at A, so you see here is the A, see A. Okay, so what makes the inclination change only is 1 decade before the value of the break frequency, and the frequency decade after the A, okay, the break frequency. So the rest of it is no change of the inclination, so only this matter. Okay, so we don't write this because it will have the same inclination, the slope, so we only consider 0.1a and 10a. So come back from here. So if 1 I consider 0.1 and 10. Okay, so means if it's a pole, means let's say this is 1, so 1, here is the 0.1, here is the 10. So this is how the thing happen, right? Then now we know 2 is the 0.2, 20, and 3 is a 0, 0.3 and the 30. Okay, so pole 3, pole at 0.1, 0.2, 0.3. So we know that like if this is the pole at 1, so it's a pole, so it's decreasing, the slope is decreasing, so it start is a negative here, right? 0.1 start is negative 45 dB per decade, so negative 45, negative 45 until start 10 stop. Okay, 10 stop, because start from 10 is no inclination. With no inclination you write 0. Okay, 0, 0. So same to 2. If now this is negative 2 because pole, right? So 0.2, 20. So start from 0.2, negative 45, because it's first order. So before 0.2 is a 0. Okay, then negative 45, negative 45. So stop at 20, because start from 20 here is 0 inclination. So 20, 0, 0. So when pole, sorry, this is 0. When 0 at 3, 0 at 3 means it's increasing. Like this is 3, so this is 30, this is 0.3. So it's in the way like this. So 3, 0.3 increasing is 45, 45, 45. So 30 is 0. Right? So from here we can, lastly you sum it, negative 45, negative 90, sum them is negative, cancel, cancel, negative 45, cancel, cancel, 0, 45, 0. So this is what we will draw based on this answer. Plot this answer. Okay, then next. Okay,